I will discuss ray optics 2, reflection of light. In the previous video, we already discussed about definition of reflection. I will start from here. Bouncing back of light from the reflector to the same medium is nothing but reflection of light. From this surface, reflections are possible. Actually, the surface from which reflections takes place is nothing but reflector. So, this plane surface, there are some terms related to reflection of light in case of plane mirror. What are those terms? We will discuss. Terms related to reflection of light. If any light ray striking on the plane surface, incident ray, if you observe, the angle made by incident ray unto the normal is known as angle of incident. The first term, angle of incidence, denoted by I. The angle made by incident ray and normal is known as angle of incident. The angle made by normal unto the reflected ray is known as angle of reflection. Next term, angle of reflection are defined as the angle made by normal and reflected ray. The angle made by normal and reflected ray is known as angle of reflection. And coming to the angle made by reflected ray and to the transmitted ray. Actually, this is the incident ray. If I extend this incident ray hypothetically downward, so this become incident ray. We can also treat it as a transmitted ray. Why? Because light is transmitted to the another medium, and imaginarily you can take this straight forward. So this is denoted by letter delta, is called angle of deviation. Angle of deviation, delta. If I define the angle made by transmitted ray and reflected ray, the angle made by transmitted ray and reflected ray is nothing but angle of deviation, delta. Transmitted ray, or you can write the angle made by incident ray. You can also write incident ray, no problem. Incident ray and reflected ray is nothing but angle of deviation. And coming to this angle, what about this angle? Actually, this is the angle between incident ray and to the surface reflector is known as alpha. Here, alpha is treated as a glancing angle. So, I will write here glancing angle. Alpha. The angle made by incident ray and reflector. The angle made by incident ray and reflector is nothing but glancing angle. These are very important terms we should know so that it is easy to analyze the behavior of light in any kind of situation. Now we will discuss laws of reflection. What are the laws in case of reflection? and we will do some geometry regarding this diagram also. Laws of reflection. We have two laws in case of reflection. First law, incident ray, normal, reflected ray, all lie at the same point and in the same plane. Incident ray, normal, reflected ray, if you see here, all lie at the same point and in the same plane. Same plane means same xy plane. Suppose if I incident any light ray by the torch this way, from the reflector the incident ray moving that way, means they are lying in the same plane. Suppose this is x-axis, y-axis, xy plane. Now incident ray and reflected ray lying in the xy plane. If you observe, this is z-axis. If I throw any light ray through yz plane, now the light will be like this. Incident ray, normal, this become normal, reflected ray will become like this. Always they are lying the same plane, like this, like this. That is first law. And coming to second law, angle of incidence is equals to angle of reflection. That is, angle I is equal to angle R. Suppose, for example, if angle of incident is equal to 30 degree, then angle of reflection also 30 degree. These two are equal according to laws of reflection. Second law, angle of incident is equals to angle of reflection. If I is 30 degree, then R has to be 30 degree. So these are the two laws in case of reflection. Now we will discuss what are the types of reflections on the basis of this. Actually, we have two types of reflection types. First one is regular or specular reflection. And the second one is irregular or diffused reflection. Regular or specular reflection of light types. The first type is regular reflection. Suppose there is a plane surface, the surface is smooth, from which reflections can able to take place. Imagine a parallel beam of light incident on the plane surface. We already discussed light follows laws of reflection. Angle I is equal to angle R. So from the normal, this reflection takes place, and here also reflection takes place. In this way, we can observe reflection rays also parallel beam of light. So if the reflection is as in the diagram, this kind of reflection is known as specular or regular reflection. Okay. If you can see here, light follows laws of reflection. you can observe this. Angle I is equal to angle R. It follows laws of reflection. Even first law and second law, light follows. Coming to next type, that is irregular reflection. Irregular or diffused reflection. These reflections are possible to taking place if the surface is irregular. Imagine the situation, there is a irregular surface. This is not smooth. This is a rough surface or irregular surface. Surface is irregular. Now imagine parallel beam of light is incident on this surface. Light want to follow laws of reflection, but as it is a irregular surface, if you observe from the normal, this light ray, I want to differentiate it. This is the first incident ray. If you observe, this ray may be moving this way and this ray will be moving this way and this ray will be moving that way, like this. If you observe blue colored lines, these are reflected rays. After reflection, these are moving different paths. Means there is no regular pattern. They are moving in random directions. So that this kind of reflection is known as diffused reflection.
But whatever it is, light always follows laws of reflection. Even the surface is irregular. No doubt.
Now we will do some geometry regarding this diagram, and we will discuss what is the relation between delta and alpha, delta and angle of incident or angle of reflection. If you observe from the diagram, we already know mathematics basic language for physics. This is a straight line. If I extend this straight line gives 180 degree. Straight line gives 180 degree. From this, I can write I plus R plus delta is equal to 180 degree. Just now we discussed that angle I is equal to R. Angle I is equal to angle R. So that can I write I plus instead of R, I also plus delta is equal to 180 degree. I plus I 2I. 2I plus delta is equal to 180 degree. Now delta become 180 degree minus 2I, or delta is equal to 2 into 90 minus I. You can write delta 180 minus 2I plus 2I, that side minus 2I. This is the relation angle of deviation and angle of incident. Since I is equal to R, you can also write here R, no problem. Relation delta and I, angle of incident. Once observe glancing angle. Glancing angle alpha. Can I say that is 90 degree? This is 90 degree. Yes. 90 degree is equal to alpha plus I. alpha plus I is equal to 90 degree. From this, glancing angle alpha become 90 minus I. Alpha is equal to 90 minus I. Can I take this alpha and put it over here? 90 minus I, 90 minus I, alpha. Suppose this is equation number 1, equation number 2. From 1 and 2, delta is equal to 2 times alpha. This is the relation between angle of deviation and glancing angle alpha. Or you can write alpha become delta by 2 also. How we will do one example on the basis of these relations. Example, glancing angle given 30 degree. For the plane mirror. Find angle of deviation. Angle of deviation. Glancing angle. From the diagram, glancing angle given 30 degree, since alpha is equal to 90 minus I, alpha is equal to 90 minus given glancing angle 30 degree, alpha is equal to 90 minus I. From this we can write I is equal to 90 minus alpha or 90 minus 30 degree. I will get 60 degree. I is equal to 60 degree. But I know delta is equal to 180 minus 2I. 180 minus 2I. So 180 minus 2 into I is 60 degree. 180 minus 2 into 60, that becomes 120 degree. 120 minus 180 degree. So finally this becomes 60 degree. 180, 120, 0, 60. 60 degree. So angle of deviation is 60 degree. You can cross check it. I got delta is equal to 60 degree. What is the relation between delta and alpha? Delta is equal to 2 times alpha. Or alpha is equal to delta by 2. What is delta? I got delta as 60 degree. 60 divided by 2. So 30 degree. Alpha is equal to 30 degree. Yes. Given alpha is equal to 30 degree. So what we have done is absolutely correct. Now we will discuss about plane mirror.
Please do hit like and subscribe for more videos. Thank you one and all. Thanks for watching.